Okay, so good evening all and welcome back to the second week of TA live sessions for AI knowledge representation and reasoning. So first of all, can you hear me and is my screen visible?
Yes.
Okay, thanks for confirming. So let's get started with the content for today. And like we discussed in the previous live session, we'll be covering some questions from week 1 and some questions from week 2 today. And then next week we'll discuss questions from week 3. So last live session we had left our question answers at the Vinograd schema question. So let's resume from there. Okay, and this is the first question in front of you. So question 16, which says that the Vinograd schema involves presenting a sentence to the user and asking a question. Identify the true statements that are relevant in case of Vinograd schema. So which of these options do you think would be applicable or correct in this context? Any guesses based on what you might have seen in the lecture videos? Okay, let's go over the options one by one and see how that how each of these might be true or false. Okay, so the first option says that the sentence is chosen from one of two sentences with only one word changed, right? And that is true in the context of Vinograd schema. So option A should be correct. Option B says that the question can be answered by searching the internet. This doesn't seem to be relevant to Vinograd schema, so we'll say that this is false. And then option C and D also seem to be correct because they say that the question gives you two options for the answer, and the question involves anaphora resolution, right? So options A, C, and D are correct. If any of you are confused about these, what exactly these options mean, we'll be discussing some examples on Vinograd schema just after this question, and hopefully after that things will be more clear in case they are not entirely clear as of now. Okay, so let's quickly move to question 17, which has an example of Vinograd schema or anaphora resolution. Okay, so question 17 gives us a sentence which says that the trophy would not fit in the brown suitcase because it was too small. Okay, and the Vinograd schema question is what so we have to ask what exactly is the Vinograd. We have to answer what exactly is the Vinograd schema question, right? So what do you think would be the correct answer in this case? So remember, I emphasized on this word it when I was reading the sentence. The trophy would not fit the brown suitcase because it was too small. D, right? So some of you say that option D is correct in the chat box. Okay, there are some votes for other options as well, but as it turns out, we are interested in what exactly does this word it refer to in this whole sentence, right? Because depending on the context, this word, if we change one of the words in this sentence, this word it could refer to a different thing, right? Here let's see what does it refer to. The trophy would not fit in the brown suitcase because it was too small, right? So here it's clear that whatever it is referring to is small, right? And here from the sentence we can make sense that the suitcase was small, and as a result of which the trophy was not fitting inside it, right? But if we change this word small to big, right, then the sentence would read the trophy would not fit in the brown suitcase because it was too big. In that case, what do you think would it refer to? trophy, right? Yeah. So you might have observed that by changing just one word in the sentence, what exactly it is referring to is changing, right? So that is an example of anaphora resolution, and an example of the kind of questions we ask in the Vinograd schema, right? Let's look at another example, or maybe we don't have another example, but I hope that gives you some idea of the kind of questions you might be asked with reference to anaphora resolution. Okay, so any doubts in the previous question before we go on to the next one? Okay, that's great. Then let's go on to question 18 then. So question 18 is again an example of a recall based question, the ones some recall based questions we discussed in the previous live session, and today also we have a few of them. So this is another recall based question. So a domain in logic is, which of the following do you think would be applicable to a domain in the logic?
The option A.
Okay, we have a vote for option A. Do you think any other options might be correct? B. So we have another vote for option B. So both of you are correct. Options A and B both seem to be true in case of domain, because as we know, a domain is also known as a universe of discourse, and it can also be said to be a set of individuals a logic language can talk about, right? A very simple example could be, let's say we have a function that calculates the square of a number, square of a integer, let's say, right? Then the domain of that function would be the all the set of integers that could exist, right? That is an example of domain. We might have also come across domains and ranges in the context of functions in high school mathematics, and you could draw that analogy over here in logic as well. Okay, that was straightforward. Option C and D are clearly not relevant and hence false. Okay, so let's move on to question 19 then. So here we are asked about situational knowledge. So which of these options do you think would be relevant to situational knowledge over here? So emphasize on the word situational. So this refers to something relevant to a specific situation. Again, this is also a recall based questions. If you might have seen the lecture videos or the slides, you would recall it.
The option will be B or D, sir.
Okay, so we have some vote for options B and C. Any other options do you think would be correct?
Option B or D, sir.
Okay. So all of you are correct. It's just that in this question we have all options to be true. Okay, so situational knowledge is a knowledge of stereotypical or typical situations in the world. It can be represented in scripts as defined by Roger Schank. It can be represented in frames as defined by Marvin Minsky, and it is also useful in understanding events using abduction. Okay, so again, we won't be talking much about situational knowledge later in the course, but it's good to have this awareness of the different types of knowledge that we have. And this is also a recall based question, so nothing much to do here other than just remembering that there is a concept called situational knowledge. Okay, and we might revisit frames and scripts sometime later in the course in one of the weeks, but yeah, that's about it. So one thing to take away or notice in the questions we have discussed till now is that we have had multiple questions in which multiple options have been correct, right? In the previous question only two options were correct. In this question all the four options were correct. These are called multiple select questions. Okay, and you have to be careful when you answer assignments or the final exam about whether the question is multiple select or multiple choice. Usually when it's a multiple choice question, uh, one of the options will be correct. When it's a multiple select question, multiple options will be correct. Okay, so just be careful when you answer, so that uh, even if you answer, let's say you select some of the correct answers from a multiple select question. Let's say in the assignment this question was asked and you selected the first three options only, you won't be getting partial marks, right? um, I'm not sure how that is graded, but it's better to select all the correct options rather than just select a few of them, or select. You also have to be careful about not selecting the wrong options, because even if you select two correct and one wrong options, I don't think they'll be assigning marks, right? So just be careful of that and practice these questions in the practice assignments that will be uploaded. Okay, so I'll stop there with the advice, and then we can move on to the week 2 questions. Um, okay, so this is the first question from week 2, and this says that when we say that logic is formal, what do we mean? Again, this is also a recall based question. Okay, so someone in the chat box, so Navya asked, how can we identify? So maybe I'll give you an example. Right, so see these kind of questions where you have these circles to select, here only one option would be correct, and when you have these check boxes, here multiple options will be correct. Okay, so be careful of that. You can even practice this prerequisite assignment, right? So here let's say I select this first option. If I change my mind and I want to select the second option, the first will get deselected automatically, right? So this is only one of these can be correct. But if you have these check boxes, multiple of these you can select for your answer. Okay, so that's how you can identify. Okay, coming back to question 20. So when we say that logic is formal, what do we mean? So this is a multiple select question, which means multiple options will be correct in this among these four options given to you. And multiple choice basically would mean that among the multiple choices given to you, only one would be correct. So which of these do you think would be true among A, B, C, and D?
Option A, B, and D.
Okay, so we have vote for option A, B, and C. So B and C are correct, but option A is not really applicable here, because we are not really dealing with any official uh, thing of sorts, right? Here when we say formal, we may mean in terms of the formal logic, not in terms of the formal word as we mean it in the usual day-to-day English conversations, right? uh, when we say the logic is formal, we mean that the arguments have rigor, okay, and that a conclusion is acceptable based only on the form of the argument. Okay, again this is also an example of a recall based question, and these are just some definitions that you might come across in the lecture videos on the slides. And you don't need to worry too much about remembering everything, just that the first 1 or 2 weeks, or maybe the third week as well to some extent, have more to do with definitions, because we are introducing new concepts and new terminologies. So there are more recall based questions over here, but as you move forward in the next few weeks, we'll be having more applications rather than just recall based questions. Okay, okay, then this was also straightforward. Let's move on to question 21. Again, this in this question we are dealing with the definition of a knowledge base itself. So which of these do you think would be applicable to a knowledge base?
Option will be A and B.
Okay. So remember that a knowledge base could basically contain facts about any situation that we are talking about. Okay, it doesn't necessarily have to be about, let's say, Homo sapiens, right? So it can be about any other species as well. It's just a collection of different facts that we are going to deal with and process further for logic and reasoning, right? So option A would, in that case, would be false because it's not necessarily restricted to Homo sapiens. Option B would also be incorrect because it's not something again confined to the domain of computer science. It is a set of sentence of all of which are accepted to be true, and it is a set of premises or axioms. Okay. So the correct options are options C and D. Okay. Again, straightforward question itself. So let's move on to question 22. So this brings us back to the discussion on entailment that we were having in the previous live session, right? So this asks, what is entailment? And entailment entails, which of these options do you think would be relevant to the concept of entailment? So this symbol over here is alpha, in case this might be difficult to read. So this is option A, says that stating a sentence alpha is possibly true given a knowledge base, and similarly alpha in the other sentence. So which of these do you think would be true?
Option will be B.
Okay, so we have vote for option B, which says that stating that a sentence is necessarily true given a knowledge base. Any other thoughts? Okay, let's check the solution. So as it turns out, it is actually option B which is correct. And again, this is an example of a multiple choice question where only one of the options is correct, right? So entailment basically means that stating that a sentence alpha is necessarily true given a knowledge base, right? Um, so this could mean something like, let's say our knowledge base contains some facts like uh, Raju is 12 years old. Raju goes to school, okay, which contains only two facts, okay. Based on that, we can say that it is necessarily true that Raju is alive, right? I know it's a very obvious and a very absurd thing, but it is something that is entailed by the knowledge base. Okay, so I'm just giving this example to motivate the concept of entailment. But there are other things that we can derive based on the set of facts given to us and the kind of reasoning we are allowed to do. We will also see some of these concepts later on in the course in the next coming few weeks, but we can use some reasoning machinery to arrive at some new facts given a set of facts in the knowledge base. These new facts may or may not always be true, okay, and that is what will differentiate a deduction from an entailment, which will always contain entailment which is always necessarily true. Okay. Khalid, you had a question, I think.
Sir, entailed something we can say implies like that.
Entailed is
Knowledge base implies so on. So Raju is not alive or whatever example.
so implies, I'm not sure if we can always say that it's always an implication, because let's say we have an implication that P implies Q. In order for us to imply something, we also need to have that P is true. So if we have P implies Q and P is also true, then Q being true will be an entailment. Does that answer your question?
Sir, right. Done.
Yes. Okay. Let's move on to the next question then. So this again is a question, the next question, question 23, is again what we were discussing just a while back, the difference between entailment and a proof, right? So a proof in logic, what do you think is, which of these options do you think would be relevant to a proof? So remember that just a while back I was mentioning that given a set of facts in the knowledge base and a set of rules to for us to do some reasoning, we can arrive at some sentence or some fact, and that may or may not be true. Okay, so we have a vote for option A. Which of the other options do you think would be correct? Here multiple options could be correct.
Option B, sir.
Option B, okay, one vote for option B. What do the others think?
Option D, sir.
Option D, okay. So let's look at the options one by one. So as we discussed a while back, proof does involve the rule of use of rules of inference. So option A is correct. Let's look at option B. Option B says that involves determining whether a sentence alpha is true or not. So this is a tricky part to understand about proof. So the thing is, when we do a proof, we arrive at a new fact given a set of facts using a set of rules of inference. Okay, but whether that fact is true or not, that is something that we do later on, not while we are arriving at the new fact, right? So the process of proof in logic is not involved with what truth value is given to the sentence, a new sentence that we derive. Because of that, option B would be incorrect. Okay, and option C and D would be correct, because proof is a syntactic process, right? So it has nothing to do with the meaning of the sentence. It is a mechanized process devoid of the truth value of sentences. It involves a syntactic process devoid of the meaning of sentences. Okay, if it had involved meaning, we would have said that it is a syntactic and a semantic process, right? For example, we might have a knowledge base that says that um, the sun shines brightly, and then we could have another sentence that says that um, the sun is the name of a torch. Okay, so this is a very weird knowledge base, but yeah, maybe we can come up with something better later on. But just to motivate, um, using this knowledge base that is given to us, we can derive that the sun is a torch. But we know that in usual day-to-day conversations, we refer to the sun as a star in the sky, right? So we derived a sentence that doesn't necessarily have a truth value true. It could also have a truth value false. When we talk about the sun in a different context, maybe a new facts or new information gets added to the knowledge base, and that changes the meaning of the word sun, or adds to the meaning of the word sun, right? So basically the point is that we can arrive at new information using proof that may or may not be true. Okay, so there's a hand raise. Varisha, you had a question.
If we know that KB like derives P, so is it obvious that KB will also entail P? Like what is the relation between derive and entailment?
Right. So anything that can be entailed can also be derived, right? Because once we derive some new information or some new fact, then we look at the truth value of that new fact. If that new fact always has the truth value true, then we say that that is an entailment. If that new fact doesn't always have the truth value true, it can also take the truth value false, then we say that it is just a new fact, it's just a derivation. Does that answer your question?
Does not always has to mean that it entails P as well.
Sorry, your voice got cut off. Can you repeat?
So if we know that KB derives P, it does not always have to mean that KB entails P as well, right?
Yes, it does not always have to be true. It depends on what kind of information is available to us in the knowledge base. So if the knowledge base can derive p, and it is also given that some other variable implies p, and that other variable is also true. Let's say r implies p, right? And r is true, and we derive p using the knowledge base. In this case, p will always be true because of the other facts given in the knowledge base. So in that case, p will be an entailment, but in other cases it may not be. Does that sound good? Okay.
Sir,
Yeah.
sir, just being something where information being true, is there anything to do with that unless we prove it? That is any entailed statement we may not able to prove also. That is coming under concepts of soundness and completeness. I mean, my question is, whatever is entailed is
Uh-huh.
by default is proved.
um I think so, because whatever we what so entailment basically refers to something that is always true given the knowledge base, right? So
Sir,
given the facts and given solely the facts contained in the knowledge base, if we arrive at a sentence that is always true, uh, we can say that we can say that that statement is always true because we arrived at that, right? If you're not even able to arrive at that, then we can't even assign a truth value to it. You get my point?
okay, sir.
But I get where you're coming from, the concept of soundness and completeness. um, Let me so do you remember which week of the course talked about soundness and entailment? Let's go revisit the lecture slides
Yeah.
to clarify the confusion.
Yes, sir. Is in
Week 2, is it?
no, sir, not the. I mean, you said anything entailed is by default true.
Yes.
But all not unless true unless we prove it. That is the question.
So here I am not referring to proof in the sense of the usual proof that we do in like mathematics or something. By
Okay.
proof I mean a set of applications of a set of rules of inference and arriving at new facts.
Okay, sir. Done, sir. Okay, sir. Right.
Yeah. So
Yes, sir. Thank you.
let's just we'll go through the lecture slides to see if my concept is also slightly incorrect. So does anyone remember if we have the concept of soundness and completeness over here? Let's search
Yes,
for
sir,
it.
it is. It is there.
Okay. Yeah, thanks for pointing that out. That we have that. So okay, so here basically yeah, so this is a good example. So this basically gives us a knowledge base. I hope you can see my cursor, right, when I'm moving it.
Sir.
Okay, so this is an example of a knowledge base, and these are the small squares are the facts given inside it, right? So we are applying the rules of inference, and then we are arriving at a certain set of new facts that are not in the knowledge base. For example, this one, and this one. Now these may or may not always be true, right? Let's look at this new figure now. So this is our initial knowledge base. Okay, now this sentence, this boundary essentially tells us is basically the set of sentences entailed by the knowledge base, and the blue ones, the blue dots are the provable statements. Okay, not sure why all these boxes are also not blue colored. um, let's look at the definition of entailment. Okay, so here is what entailment is. An entailment says that um, given the knowledge base all the other sentences in the language have truth value that are determined or entailed. We also say that entailed sentences are true. A sentence alpha is said to be entailed by a set of sentences S in the knowledge base if the sentence is necessarily true whenever the knowledge base is true. Yeah, so that is what we did arrive at. Okay, so this is the knowledge base given to us. These are all the statements that are necessarily true given the knowledge base, and because we assume that all the sentences in the knowledge base are true, and that is a given based on the definition of a knowledge base itself. Now let's look at provability. So provability says that yeah, the derivation is a proof, right? So we use the rules of inference, apply to the sentences or facts in the knowledge base, arrive at a new sentence. That sentence is provable given the knowledge base, but may or may not be true. Okay, so the concept of soundness and completeness tell that given the knowledge base and the reasoning algorithm, which other sentences in the language are necessarily true, that will be entailment, and proof will be which other sentences in the language can be produced using the reasoning algorithm. Okay, so this figure basically tells us that there are some provable statements that are not necessarily true given the knowledge base, right? But there are also some sentences that are necessarily true and that can also be proven given the knowledge base. I think this is just to differentiate the set of entailed sentences from the provable sentences. Anything that is within the set of entailed sentences should also be provable. Okay, and
Sir, and is it vice versa also?
no, every provable sentence may not necessarily always be true, right? That is what differentiates the entailed sentences from the provable statements. So these few are outside the boundary of the entailed statements because they may not always be true, but an entailed sentence will always be true. And about the soundness and completeness, so soundness and completeness are specific to the reasoning algorithm that we are applying, not the statements themselves. Okay, a logic is sound if it only true statements, if it can derive only true statements. Okay, so basically if we apply some logical reasoning machinery that can only give us sentences that are within this boundary that is given to us in this figure, then that is a sound logical machinery. It is complete if it can derive all true statements. Okay, um, if it can derive all of these true statements, then we say that the logical machinery is complete. Okay, and a
What is that provable statements inside the boundary?
a provable statement inside the boundary is something like this. So you had some facts in the knowledge base, you applied some rules of inference, arrived at some new sentences, right? If these sentences happen to be always true, they will be within the boundary of the sentences entailed by the knowledge base.
Okay.
If they are not always true, they will be something like these points over here, which we can prove, but we cannot say that these will always be true. Okay.
Got it. Thank you.
Okay, so that resolves the I hope the issue. Thanks for pointing that out or asking that question. So Varun says that could you please help with the recording links of these sessions? Sure, Varun, I'll point to that. But before that, there is a hand raise. So do you have a question, Ashmi? Okay, maybe that was by mistake. So yeah, so Varun, to answer your question on Swayam again, so here you have a section called problem solving session. You can click this link over here and that will lead you to the appropriate links for each week's live session recordings.
Yeah, thanks, Ritviz. I was actually doing that, but it's not taking me to that recording session.
So
I
if you
don't know
click
what's
on that,
it.
it will lead you to a
Yeah.
Google Sheet, and there
Yes.
you will have the recordings for each week. The links available over here. Can you see that, or is it not
Oh,
accessible?
that's a YouTube link. That's what it is it?
Exactly. Yeah.
All right. Okay. No, earlier it was not there. Earlier it was the column C link. That is what I was able to access, but I
Right,
think
right.
this YouTube link came a little late. Okay.
Yeah, yeah. I uploaded the video only yesterday because I was traveling for
Oh,
a
all
while.
right. Yep.
So yeah, that's
Got
why
it.
I think.
All right. Yeah. Thank you so much.
Yeah. Okay then. So coming back to the questions. So we have discussed proof. Okay, let's move on to the next question then. Okay, so this deals with soundness and completeness, what we were just discussing. So question 24 says that the logic machine is a set of rules of inference operating on a given set of sentences. We say that the logic machine is sound if which of the following do you think would be correct? Yeah, is there a question? Uh, Diavna, is there a question? Okay, no worries. Maybe it was unmuted by mistake. So, which of these options do you think would be correct in the case of a sound logical machinery?
Maybe the option B or C.
Okay, so
Appears to be C statement when it can drive only true sentences, only
okay,
true.
okay, that's true. So remember the concept of sound, that soundness that we just discussed. Logical machinery is sound if it can derive only true sentences. Okay, and that makes option C correct. And option D is also a restatement of option D itself, option C itself, right? If a logical machinery can derive only true sentences, it cannot derive any false sentences, right? So that makes option
Then
C.
what about A?
Option A would refer to a logical machinery that is complete, not sound.
Those
Okay, so a logical machinery can be sound, complete, or both sound and complete. Okay, so if it is only sound, it can derive only sentences that are true. If it is only complete, it can derive all the sentences that are true, all the possible sentences that are true. If it is sound and complete, it can derive all the sentences that are true and only the sentences that are true. Okay. So if I have to go back again to that diagram that we were talking about, right? A sound logical machinery essentially would derive sentences that are within this boundary. Okay, that are only that can only be true. Okay, but a sound logical machinery may not be able to derive all the true sentences. Okay, it may be that a logical machinery that we have is only able to derive this one or two of these blue dots given to us, or three of these, let's say. Okay, only a subset of the true sentences. Then it's sound because it derives only true sentences but not complete. If a logical machinery is complete, it derives all the true sentences. So that means that it derives all the sentences within this boundary. Additionally, it can also derive some other sentences that are outside the boundary, but they might not be true. Okay, so let's say a logical machinery derives all the points given in this figure. Okay, some of these are true, some of these are not true. That is a complete logic machinery. But if a logic machinery derives only the sentences within this boundary and all the sentences within this boundary, then it is both sound and complete.
So what happens, Ritu, in case of machinery is defining the sentences which are true but outside of this boundary, which are the blue dots which you see outside the boundary, which are true.
So dots which are outside the boundary, even if they are assigned the truth value true, they might be context specific. Like maybe in some cases they happen to be true, but they will not necessarily be true in all cases given the knowledge base. So in that case, we cannot say that they are sentences that are entailed. We can say that there are sentences that are derivable or provable. Um, does that answer
And
your question?
and entailment is with respect to the boundary that we have defined.
Yes. We have defined by default because of the knowledge base given to us. It's not something we ourselves define, but it's defined because of the knowledge base given to us.
Right. Okay. Okay. Yeah. Thanks.
Okay. Thanks for your question. Okay. So let's move on to question 25 then, which again deals with completeness. So which of these do you think would be applicable in case of a logic machinery that is complete?
Probably A and D.
So in this case, A only would be correct because um, it can so a complete logic machinery can derive sentences that can take the truth value false, right? As we saw in this figure, as long as the logic machinery derives all the sentences that could be true and additionally some more sentences that may or may not be true, we will say that it is complete. As long as it covers and derives all the sentences that could be true. Okay, other that will necessarily be true, not could be true.
Well, in that case, our our definition of completeness is a logic is complete if all true statements
Mhm.
in that language can be proved. Right? That's a
Yes, that we can put it that way. And in
so
addition
in
to
that
that,
yeah.
yeah, go ahead.
No, in that case, that machinery would be only generating the true statements of that defined boundary, right? Not the false statements.
No, so it can derive sentences. So basically, it can derive, let's say, a set of 10 sentences. Okay. Out of those 10 sentences, let's start from the scratch. So let's say knowledge base has two statements. Okay. Using some logical machinery, we can derive 15 sentences. Okay. Out of these 15 sentences, 10 will always be true. Okay. So if we have some logical machinery that can derive all these 10 statements that will always be true, plus it is also allowed to derive two or three of the other statements that may or may not be true. Okay, so let's say that the logical machinery derives 12 sentences. 10 of those are belong to the set which are always true. Two of those are those that may or may not be true. We will still say that that logical machinery is complete. Okay, but we cannot say that logical machinery is sound. Now let's say logical machinery derives only 3 sentences. Okay, but these 3 sentences always fall in the set of those 10 statements that are necessarily true. Then we will call that logical machinery sound but not complete because it cannot derive all the 10 possible true statements. Now we have a third logical machinery, let's say, that always derives the 10 necessarily true statements, right? As well as um, it derives all the 10 true statements, right? And it does not derive any other statements out of the leftover 5 statements that could be false, right? That machinery would be called sound and complete. Does that somehow resolve the confusion, Varun?
Yeah, to an extent, I just need to digest that.
Yeah, I know I put it in a slightly confusing way, but maybe we can take some example or
Yeah, I think
So
examples
if
would be better.
like so if a logical machinery like derives sentences that can be true and also like all the sentences which are true, then it is sound as well as complete.
yes, that's right. So
Okay.
let me search for some statement, some example that can explain soundness and completeness.
Yeah, I think putting a context to an example would
Yeah.
be here.
Sir, can we say in a single line,
Mm-hmm.
all the derived sentences are true, then it is sound. And all the true sentences can be derived, then it is simply complete. Is it possible?
Yes, we can say that.
All the derived sentences are true means sound. All the true sentences can be derived means complete system.
Uh, yeah, sorry, I wasn't listening. I was searching for something. Can you please repeat?
All the derived sentences are true,
Yes.
then the system is sound.
Yes,
All the true sentences are can be derived, then it is complete.
that's right. That seems correct.
So vice versa, right? Both.
When the system is complete and sound, then vice versa.
So if the system is complete, all the true statements can be derived. Okay. When the system is sound only, some of the true statements can be derived, but not all true statements can be derived. Is
Please
it
come again. Please come again.
so? Basically, what I'm saying is, let me try to draw it. Okay. So we have soundness and completeness. Okay. Let's say a logical machinery derives only true statements. Okay. By when I say only true statements, that doesn't mean that it can derive all the possible true statements. You can think of it as someone who always speaks the truth. Okay. Doesn't necessarily mean that person will speak all the truth in the world all the time, right? But whenever that person speaks, the person will speak the truth. That is an example of soundness. Okay. Now let's say we have another person that can tell all the possible true things in the universe. But in addition to that, that person can also say some things that are false. Okay. We will call that person complete because that person can say all the statements that are true. In addition, we will still allow the person to say some statements that may not be true, that can be false. That is an example of complete. Now, let's say there is a third person that can tell only true statements, can never lie, and can also tell all the possible true statements in the universe. That person will be called sound and complete. Is that helpful somehow? I was trying to find an example, but I'm not able to immediately.
Could you
Yes, yes, got it, got it.
please repeat the last statement about being sound incomplete?
So, a person would be sound and complete when the person can uh, say or produce only true statements and all the possible true statements in the universe. Okay. So, yeah, I'll
Can
just.
we take a scenario relatable to health?
I'm not sure. I was trying to come up with something, but I'm not able to come up with something very concrete. So let me think over it and come back with an example maybe in the next live session. Okay? Because I can try coming up with something right now, but that maybe in hindsight that will turn out to be not a good example. So it's better to take some time rather than confuse with a bad example. So allow me some time and then maybe I can come back with a proper example in the next live session. Okay.
Yeah, sure.
Okay then. So let's move on to the next question then. So this question asks us, what is a valid rule of inference? So which of these do you think would be correct?
B and D, probably E.
That's right. I think you covered all the correct options. So A valid rule of inference would be a basis of a deductive inference, right? Is based on a tautological implication. A tautology is essentially something that is always true. It cannot take the truth value false. It is always true. Okay, and is a sound rule of inference. Of course, when it is a tautological implication, which means it is always true. It has to be sound, right? So a valid rule of inference is option B, D, and E. Right? A and C are not applicable because abduction involves us making hypotheses that may or may not be true, and inductive inference has us making generalizations again that are mostly true but not always true. There are always exceptions. Okay. Okay, then let's move on to a question. Oh, I think I renamed question 27 as 28, but anyway. So, which of these do you think are atomic sentences in propositional logic? Okay, remember atomic sentence from the lecture slides. Okay, as you might infer from the name atomic, it's that it's
Except B and E.
okay, except
All
B
are
and D. What about option D? Remember, this option D says that this sentence is false,
acha acha.
but
Yes, yes.
this is
Yeah.
kind of
Not
a,
D also.
yeah. So this is a kind of a vague sentence, right? This can mean multiple things. This, we don't know what this is referring to, right? So
My bad. I read B, this as B. The
no problem,
PhD.
no problem. So yeah, you were correct about the other two options that you said. That option. So let's go through the options one by one. So option A is an atomic sentence. The giraffe is a vegetable. Yeah, the statement is absurd, but it is an atomic sentence. Okay, this would have a truth value false, right? But it is still an atomic sentence, right? Please pass the ketchup. This is not an atomic sentence because again this is a vague sentence, ambiguous sentence. We don't know who it is referring to, who is being asked to pass the ketchup and to whom, right? The moon is larger than the sun. Again, this is also atomic sentence, but it is uh, absurd. It can take the truth value false. This sentence is false. Like I was saying, this again is a vague sentence. It cannot be atomic. What did Biden say to Macron? Again, this is also not atomic sentence because it is a question mark at the end. Okay, so this is also sort of ambiguous and doesn't fit into the definition of an atomic sentence. Yeah, is there a
Sir,
question?
sir,
Yeah.
the option D
Mm-hmm.
appears to be matching with the situation last week. We found that barber unable to or able to shave himself. That question raised.
Okay.
Maybe a similar sentence is D here.
Um, so here we don't know exactly what this statement, this sentence, this word, this is referring to.
Okay,
This word, this could refer to the sentence itself. This sentence is false.
okay,
In
sir.
that case, it will be a paradox. Yes.
Okay, it's not a paradox now.
No. This word, this over here, this could refer to something altogether different, right? Let's say another
Okay,
fact comes in our knowledge base, which says that the sentence is something else, and then this is another fact. This sentence is false. In this case, in which case this word would refer to some other thing, some other entity. Okay.
okay. But can we call it as a paradox like
N-
that? And we
no,
cannot put this in that group.
no, I don't think we can put it in that group.
Okay, sir. Done.
Okay. So, what are logically sound arguments? Um, okay, so just solely based on the framing of this phrase that you have mentioned, logically sound arguments. So, it seems to me that it refers to some derivations that we arrive at using a specific logic machinery that happen to be sound. Okay, but I would encourage you check this back with the lecture slides in case they refer to something different, something specifically different. Okay, but this is what it seems to me. uh,
Sir,
So
pardon, sir,
there's
may
a question. There's
Uh,
a question in the assignment which asks us to choose the options that lead to logically sound arguments. So in that context,
okay, is it in the week 2 assignment or like one of the graded assignments?
week two, week two.
Okay, then technically I am not allowed to discuss it until the deadline. But yeah, I would just encourage that follow the uh, yeah, follow the phrase logically sound arguments. Okay, that's the hint that I can give, or not exactly a hint. It's just restating the question. So yeah, follow this. Also refer back to the lecture slides to see if this particular phrase has been mentioned somewhere. Okay, in which case you will have a go-to answer directly. Also remember the try to look remember the meaning of each of these different options. Okay, what exactly mean? What does abduction mean? What does reduction mean? What does induction mean, and so on. Yeah, Harish, you were asking some question. Sorry, you got cut off.
sir, actually, this atomic sentences doesn't mean that the sentences which have the you can say no related logic like or and odd. It is a straightforward single sentence that is considered to be the atomic sentence. If I am not wrong.
It is, I think, atomic sentence is something that can the smallest piece of sentence that can be assigned a truth value. Okay, and it has to be not vague. Let me actually go to the slides, and oh, I have the slides open already. Let me search for atomic. Okay, the set of sentences that constitute the formal language is a set of atomic or primitive sentences or formulas. Okay, and this atomic sentences can be connected using connectives. Okay, that could then form well formed formulas. Okay.
Yeah, so that means the atomic sentences are those which doesn't have any connectivity,
Yes.
misconnected.
Not not misconnecting in the sense that I mean they are independent on its own. That is why they are atomic. Okay. A sentence that
Okay.
is connected by connectives can be broken down further into atomic sentences, but atomic sentence cannot be further broken down without it losing its meaning.
So, Ritvik, in that
Mm-hmm.
case, if I assume alpha is a atomic sentence,
Yes.
okay, and if I take that example back, like this statement is false, then
Mm-hmm.
that's an atomic sentence because it is independent of and other connective operators, right?
But it also has to be not vague, right? So in that case, this in that sentence, this could refer to some 10 different things. It's that why that is why we are saying that that is not an atomic sentence.
Mm.
Does that
So
clear?
we are not defining this in that case.
Exactly. Yeah. So this the word this could take several different meanings essentially. So it's not in that sense it's not complete on its own or independent on its own. Does that answer your question, Varun?
Yeah, yeah. All right. Yeah,
Yeah.
thanks.
Okay, then um, let's move to the next question. So this question, yeah, was there a question? Okay, maybe not. So question 29 tells us that given the following two true statements, which is A and B, is the conclusion, which is options, which is statement C, is that valid? Okay. So the two statements are: if Amog ran for 21 kilometers, then he would be tired. Amog is not tired. Therefore, he did not run for 21 kilometers. So try framing this in terms of the implication and negation. Okay. If Amog ran for 21 kilometers, then he would be tired. Amog ran for 21 kilometers implies Amog would be tired. Amog is not tired.
So I think it's B.
B. Okay, let me rewrite it. Okay, let's say that P refers to Amog ran for 21 kilometers. Okay, I'm not writing the whole thing. And then Q stands for Amog is tired. Okay, now statement 1 that is given to us, that says that if Amog ran for 21 kilometers, then he would be tired. So P implies Q. Okay, and then we are given that Amog is not tired, right? So we are given the negation of Q. So based on these two facts alone, see, if we had been given P to be true, we could say that Q is true, right? We are given that Q is not true. In that case, we can say that for sure P is also not true, because if P had been true, then Q would definitely be true. Because Q is not true is given to us in the knowledge base, which means that P is also not true. Okay, so a valid conclusion would be Amok did not run, which is what is given over here, right? So that would make this a valid conclusion. Does this answer any confusion that might be here?
So simply it is a modest tolerance.
Yes, it is a model tolerance. Any doubts there? Okay, great then. Now let's look at the last question. Okay, again this has given us two statements and a conclusion, and we have to derive whether that conclusion is valid. Okay, so the first statement is, if the tea were to be cold, then Shashank will not drink it. Shashank did not drink the tea. Did not drink the tea. Okay, therefore the tea was cold. Now do you think the conclusion is valid? So let me write it down again.
No.
No, so we have one answer, that is no. Okay, so here statement P is that tea is cold. And Q is that Shashank will not drink it. Please excuse my bad handwriting. Okay, so again we are given that P implies Q, which is that if the tea were to be cold, then Shashank will not drink it. P implies Q. We are also given Shashank did not drink the tea. So we are given Q. We are not given not of Q. Right? We are only given Q. So based on this, we cannot say that P will be true, because Q could be true due to other reasons as well. One of the reasons why P would be true can be, why Q would be true can be P, but there might be other reasons as well because of which Q is true, right? So we cannot say that P will be definitely true. So a conclusion that the tea was cold would be not valid. Okay, Yes, to Basan, to address your query, no, there is no official WhatsApp group, but you can check with your colleagues if they have any unofficial groups. But again, that would be unofficial and would not be monitored by any of the NPTL, anyone from the NPTL team, or by me or the instructor, Professor Deepak Khemani or Bhaskaran sir. So I would encourage use the discussion forum on Swayam for any doubts or clarifications. But yeah, up to you. You can check with your colleagues if you have any WhatsApp or not. Okay, coming back to the question, any doubts there? Okay, that's great then.
Sir, the same question.
Yeah.
Same question. Or any other, the question previously what you showed with the symbols. P implies Q.
Mm-hmm.
Then below that we are writing the letter Q
Hmm.
or P. Something we are writing P.
Hmm.
Can you show the same thing with symbols of syntactic or semantic?
Yeah,
What symbol must be there? P implies Q,
that's what we
comma.
did, right? Oh, you mean the symbol for implication?
Yeah. How you have to everything. Maybe syntactic or semantic or something. So just I'm giving the opposite. P implies Q.
Yeah.
If P, then we are saying Q.
Yes.
Straightforward, modus ponens.
Yes.
Then can you show me that in the form of symbols? What symbol we have to use exactly?
This is it, right?
Okay, the syntactic symbol or semantic symbol? If you don't write, if you don't want to write that line below P,
Oh, you mean to ask whether we can write this as sentences instead of P and Q?
no P and Q is there, sir. Then below
Okay.
that P you have written.
Yes.
Then you have added a line below that.
That is
Instead of
just.
drawing a line, no,
Huh.
can you show a symbol for that? Maybe syntactic or semantic or something. What should be there in that case?
This there doesn't have to be a symbol. You can put an and in between. Like
Okay,
P implies Q
okay,
and P
okay.
together derive Q.
Yeah. Now what is the symbol? What should be?
Yeah.
Yeah, is a semantic or syntactic?
This is entailment. This is syntactic. This has
Eh,
nothing to do with the meaning. So there's no semantics involved over here.
Okay, it's not entailed. Yeah, sir, entailed.
Yeah.
And this entire thing can be proved by using a truth table.
Yes, it can also be proved using the truth table.
Yes, sir, I'm done. Thank you, sir.
Okay.
Sir, I'm done.
Okay. So that kind of concludes the questions I had from week 1 and week 2. Coming back to the doubts we had about soundness and completeness, so I just came up with a simple example, okay, from mathematics, and maybe that will help somewhat, but again I'm not too sure, but let's try it out. Okay, so let's say we have y equals to square root of 4. Okay, and the possible solutions are that y can be plus or minus 2. Right, now let's say we have a logical machinery A that gave us the answer y equals to plus 2. Okay, and this gives us only one answer. Okay, let's not get into what kind of logical machinery this is, but let's just assume that there is one logical machinery A that gives us only one answer, and that is plus 2. There is another logical machinery B. Let's me demarcate this as A. Okay, B says that y equals plus 2, minus 2, and also y equals plus 3. Okay, and let's say there is a third logical machinery C that says y equal to plus 2 and minus 2. So which of these would be sound based on what we have discussed till now?
A and B is sound.
No, B is not sound. See, sound is something that can derive something that is always true. It cannot derive any false sentences. We see that B has derived for false sentence, right? Y equals plus 3.
So A is sound,
A.
Yes. A is
uh,
sound.
B is complete.
B is
Yes.
complete, and C is sound and complete.
Yes. So A is sound because it derived one statement, and this state whatever it derived was true. Okay, that made it sound. The reason why B is not sound is because it also derived a statement that is false, which is y equals plus 3. But other than that, it derived all the possible sentences that could have been true, which is y equals plus 2 and minus 2. Right? So this is complete, and C is both sound and complete because it derived all the sentences that could be true, and it also derived all only true statements and nothing that is false. Okay, so is this example somewhat helpful in understanding the concept of soundness and completeness, or should I search for something more involved than this?
If C included under root of 4, then it would not be sound and complete.
Um, if C includes under root of 4, in that case that
No,
would
sorry,
also
not under root of 4, like one any false statement. Suppose 6. 6.
yes, if C would
And
include any statement that is false, then it would be not
that
complete,
becomes B, right?
not sound. Sorry, Varun, your voice was breaking.
That becomes B, right? Like a
Yes,
complete statement.
that becomes B. The reason why I got slightly I was slightly hesitant when you asked whether we should include y equals root 4, because y equals root 4 is also true, right? So maybe we should also add that as a possible true statement, right?
Yeah.
Yeah. In which case B would also have to derive y equals root 4, and this would also have to derive y equals root 4. Yeah, thanks for pointing that out. Okay, I hope this was somewhat helpful. If not, do let me know. We'll look into some maybe a bit more proper example next time. Um, but yeah, that's all from my side for today. Is there something specific that you would like to discuss before we close the session for today?
Ritvish, one thing regarding these semantics of logical connectives. I mean, part of the session with Deepak sir, um, I got to understand that okay, some of these what's a common valid rules of inference with like modus ponens or modus tollens,
Yeah.
and there are some variations around that conjunction, addition, simplification, and so on and so forth.
Yeah.
But for a fast testing point of view, that because these statements which came as an example, so as questions,
Hmm.
a derivation of that, we need some way to process that faster. Uh, and is that the only practice? Is the only way, or is that some logical way which we should be adopting to say
So
derive it faster?
when you say process, do you mean like when we answer the assignment questions or something, or?
No, no. See, to derive those answers, the one way is that we build the table, like alpha implies beta, and alpha is given, then I am inferring beta,
Yeah, yeah, yeah.
right? And that proving that requires the table component with the true and false statements,
Mm-hmm.
right? With and or and the implication and the other what's a XOR combination
Yeah.
along with the equivalence.
Mm-hmm.
So if I during the exam if I tend to do that, then it is time taken exercise,
Yeah.
right? But is there a way using which I can derive those statements quickly? Um,
So I would say that yes, practice is definitely one thing.
mm,
Something that I used to use when I was taking the course is something like this. So I'll represent all the facts that we have in one line. Let's say we have some facts like P, Q, R, not of S, or even something like 2T or U, or something like yeah, sorry, um, A, um, and B, something like this, right? So I write down all of this in a single line, and then I use different rules of inference by drawing sort of a upside down tree. So let's say let's say we also have P implies Q over here, right? Let me just okay. So I will use P, sorry, not Q, or let's remove Q so that we can derive Q. So I'll use both these uh, to arrive at Q, okay, and then Q would be added to the set of facts given to me, so I don't have to write down everything again. I'll just have this tree. Then I can use this Q in combination with some other fact based on some other rule that is given to me, and let's say some other rule from here that can derive certain new things, and then I can keep building this tree. So this is something that I used to take, but that's just my preference. There's no specific single way of doing this, but yeah, the more you practice, the more you will tend to
yeah,
speed
but
up.
to remember, I think this is helpful. But to remember that, okay, P implies Q and P is given,
Hmm.
then you need to remember all those
Mortis,
um,
tolerance,
co-
and ponens.
yeah, common
Sorry to
values.
interrupt, but instead of using the rules of inference, like for testing the validity of arguments, there's also this another way, right? Where we make the truth tables based on the sentences, and then if all the truth values are true, then the argument is valid. So, can that also be used here?
You are referring to the tabular method, I think, right?
Yes.
Yes, that could also be used. I think that is covered in week 3 maybe. um, Yes, that could also be used. So, yeah, I agree with Varun that remembering this modus ponens and tolerance in the initial go might seem like a task, but yeah, the more and more you go through the elements of the course, you will get familiarized with them, and by the time of the examination, I think you'll have that at the hand of your tips. So it's not a matter of shouldn't be a matter of concern.
All
Okay.
right. Yeah.
And thanks for your inputs as well, Varisha. Yeah, tabular method is also something you should use. And again, if you practice more, you will get comfortable with that. I personally haven't used tabular method much, so I tend to use this one. But yeah, it's a personal preference. Yeah, so nothing like you have to follow a specific thing.
Thanks.
Okay, thanks for your questions. Basan, this recording is not yet available on YouTube. I will be uploading it today. Okay, so it will be there by tonight or tomorrow morning.
Richard, yeah, I have a concern here.
Yeah.
Anything for non-engineering students. I'm absolutely not from engineering background, not even from technology side. I'm pursuing this only for the sake of personal interest and to know more about AI.
Okay.
So you'll have to tell us the tricks and tips how to crack this and how to get more familiarized with all these concepts. Is there a book or is there something where you can understand
Uh,
it
Thanks for
from the
okay, first of all, thanks for showing interest and registering for the course to learn new things. So that's great. As for the tips and tricks, I would just say that yeah, one thing is just practice as much as you can. Not just the practice assignments given in the Swayam portal, whatever examples, let's say Professor Deepak Khemani is discussing in the lecture videos, you try writing that down without seeing the lectures for yourself and see how much of it you are able to catch in multiple iterations. As for the book, I think about the course section on Swayam should have some references, right? There's one book that is written by Professor Deepak Khemani himself, so you can refer to
Yes.
that.
Uh,
First course in artificial intelligence, McGraw Hill.
Available on yeah, it's available in Amazon. I just got to see that.
Yeah, other than
Um,
that, there are other textbooks and reference books as well that you can
okay.
look into. Um, yeah, there are some multiple references available here. Other than this, of course, there are several other resources available in terms of tutorial videos or things, not specifically by myself, but like
Okay.
other people who might have, worked in the similar domain and might have uploaded content on the internet, so you can refer to those as well. But just verify the correctness of whichever source you use to learn about the concepts, right? Because there might be discrepancies. Even in my case, I might end up saying something that may not always be true, so just cross check everything from the lecture videos, because the lecture videos have been cross checked multiple times, and they are supposed to have everything like sound and complete, as like if we can put the same thing. It's the same concept we learned today. Okay, does that answer your question, ma'am?
Slowly, I'm getting acquainted to all these terms and
Yeah.
things. Fine.
Yeah,
Thank you. Thank you.
I'm sure it will
Sir,
be. Yeah.
there is a place in the location where I heard the word some common rules of inference. There, sir, professor was telling that any rule is by default true, and that is by default tautology. But
Yes.
another location I found all rules of inference may not be tautology. Can you? I have doubt in this. Can you clarify?
I have to read up on that. Which are the sources that you are referring to? The other source?
So our materials, only, our audio and video only.
Uh, our audio and video. Which
Okay.
one?
Exactly, I don't know, but I came these two sentences. One time, any
Again,
rule means by default it is true and always true.
okay.
So any rule of inference is true. So is tautology. Another location I found all implied statements. These rules are P implies Q, then P, then Q we are saying. So
Hmm.
sometimes it may not be tautology. It may come false also.
Okay, so one thing I'm confused about here is assigning truth values to rules of inference, because they are rules, not statements as such.
Sir,
Okay, but I would encourage you post this in the discussion forum, because I'm also not entirely sure uh, how to resolve this. I would
sir,
say that yeah, rules have to be true, because if they are not true, how can we apply them and arrive at new facts, right? But yeah, again, I'm not too convinced saying that, because they are rules and not really statements. But yeah, just revisit the lecture. Maybe I'll also do that. And if there is a mention of something like this, then we will just confine to that. If there is not a mention of anything like this, then it's better to clarify it with Professor Kemani or Bhaskaran sir himself, and discussion forum will help in that. So yeah, I highly encourage you to do that.
yeah, I have that sentence now, implied sentence. Can I say
Yeah, I mean, any implied sentence is okay for that matter, right?
it
Because
is
we can just replace it with symbols. P implies Q. But you are asking
P
whether P
implies
implies Q
yeah, P
itself is true or
implies
not, right?
no, I have another one. P implies R,
Okay.
which implies in another bracket P and Q that implies R. It is uh, we, this rule is there, but it's not tautology. Okay, anyhow, I post sir. I will post in the forum and
Um,
I
Let me write down what you were saying.
P implies R.
P implies R.
No, opposite. P implies R.
Yeah, P implies R, right?
No, symbol should be this side, no, sir. Open.
No, no, here P implies R. Oh, sorry. Yes, I think I wrote a subset. What had I been writing? Have I been writing subset this far?
No. Correct one, sir. So far you are written correct. Yeah,
No,
yeah.
that is
First
reverse.
answer.
Reverse. It's opposite of C.
Opposite. P implies
Yeah,
R. Okay.
it's this
No,
one
no,
only, right? Or is it the
no,
opposite
no.
one?
Another way. Yes.
Ah,
P implies
okay, R. Okay,
R
if I
P
have been
implies
writing it as the implication symbol as something different, please apologies for that. Please correct that when you solve the assignment answers, right? Please don't use this as a subset symbol.
sir.
Yeah.
P implies R only, sir.
Yes.
Bracket close. Yeah, this implies bracket, another bracket, two brackets. No, it's over. A new bracket start.
Oh,
New
this
bracket
implies a new
start.
bracket.
Yeah, implies new bracket, another bracket.
Okay.
PRQ bracket close. This implies R.
Okay.
Now these both are same when we make it by using truth table, but it is not tautology.
Okay.
Can we? It is not tautology because not all are true. But whatever P implies are say wherever is true, the right side also is true. So we can say it is implied.
I would encourage you simplify this and
Sir.
then arrive at a simplified version of this equation and then see whether that seems to have a particular truth value.
Okay, sir. I'll do,
Okay.
sir.
So when you were saying rules of inference, were you saying like this compound rules like this or the modus ponens or tonens, to those kind of things? That
No, this entirely is not tautology.
is, this may or may not be tautology, uh, but the, the atomic rules of inference that we have, like P implies Q, like P implies Q and P that should derive Q. These will have, we will have to assume that these will be true, right?
Okay.
But yeah, for these such like hypothetical rules that we construct ourselves, it's better to simplify and arrive at a particular truth value and see if they happen to be a tautology or not.
Okay, sir.
Okay,
Sir,
and
done. Thank
once
you, sir.
again, just emphasizing, please don't mistake this subset for implication. It was my mistake, but please correct that. Okay. Yes. Anything else? Yes, there's a hand raise. Please, you can feel free to speak up. Harshil, to answer your question, it's in the Swayam portal. Um, there's a link for problem solving session. Just go over there and you'll find the recordings over there. Okay. If there's nothing else, maybe we can close the session for today. Okay, then thanks all for attending and let's meet next week.
Thank you.
Yes, sir.
A request,
Yeah.
one small request.
Yeah.
Can these interactive sessions be at least pushed by another half an hour or something? So
Uh,
because I could join quite late today. Uh,
I
by the
see. I
time
see.
I come back from work, it will be quite late. So I could not join in time.
I see. I see.
So
So the thing is that I
because it is working days, instead of 6 to 8, if at all possible, if it is just a request, can it be from 6:30 to 8:30 so that I can come in time and join?
Yeah, I understand your point of view, sir, but I think the timings have been set by the NPTEL team, and unfortunately, I don't think I can change them, um, unless we specifically have like a like request for for an exceptional case, maybe. But yeah, I think that it should be okay. You can stay for the period that you can join, and then for the rest of it, I think we will have the recording, so you can feel free to revisit the recordings and ask questions either in the comment section or there itself or in the discussion forum. Whenever you ask questions in the discussion forum about anything related to the live session, I will just encourage that in the subject just mention live session so that that will catch my attention and I can address that over there as well. Does that help some way?
Yeah, thank you, Ritesh.
Okay, thanks for your query, sir. Okay, then let's meet next week. See you all.
Thank you.